So the basic idea here was a fixed construct where this is just a square graph, right? But when you go this way and you're shrinking spaces, like say you have some sum of energy or gravity, right? And you go this way, then you're shrinking spaces. You eventually make a creation when you're reverse squaring, like the space-time, right? So for gravity, you're falling into it, right, as the spaces shrink. But this is kind of a fixed state, so all of this is called potential energy, right? And that's what causes things to fall. But it helps to produce the frickin' fusion of the sun, right? So there's a sun here in the middle, and the gravity's holding it in and helping to produce that fusion. It's a fixed state, right? So I had a similar concept, and this is just based on the news about fusion from the news. But I had a similar concept where I'm taking a cube, right? And this is a mirror back, and then all of these photocells, so that I have kind of a slit, double slit type thing here where I'm attaching photocells directly onto a mirror backing. And then I place those all in a cube with the light in the center, and I use lenses as a fixed space. So the lenses reduce. So in math, you can get a curvature, right, when you're doing a graph of squares. So that's a geometric curvature. But this gives you shrinking spaces. So you get gravity plus rainbow when it's volume by wavelength. And then you also get a shrinking aspect ratio, right? So at 1 squared, you're this size. At 2 squared, you're this size. At 3 squared, you're this size, right? So you actually grow in size. And then the time things change because wavelength is time, right? So then when you do an ion cube or whatever, and this is 1 squared, 2 squared, 3 squared in a cube, and then mathematically that turns into curvature, right? It turns into geometric Einstein space-time, right? And then so you still have these aspect ratios, you still have the rainbow effect, red, green, blue, right? You still have the shrinking spaces, gravity, and the time change, right, that we use when we have a satellite out here, as opposed to a clock on the Earth, right? So the times are different because of wavelength being involved. So you get gravity, and then you fall because you have some measure of length. Like, so this whole radius here is a distance. And since you have some measure of length, then you're taking a line segment AB, right? And so when line segment A or point A is closer to the shrinking, then it's got more energy because it's compacting, right? So when it has more energy, then it falls, and then it falls at the rate of whatever the shrinking rate is. So that's why you fall. Okay, so we also get for an energy expanding space. So when we have an atom, say, and it's got all of these electrons moving around in orbitals, they're existing in these pockets of extended space-time. So in the first orbital, you have one electron. And then because space-time is made out of light, right? Space-time is made out of light, volume by wavelength. Now, in the second orbital, then you can have 3, right, or 4 in the 2 squared. In the 3 squared, you can have 9 electrons, right? See what I'm saying? As the volume by wavelength increases, you get higher and higher amounts of electrons that you can have in each orbital. But when you add energy to the 1 squared, then that moves the electron up. Okay, so we also get for an energy expanding space. So when we have an atom, say, and it's got all of these electrons moving around in orbitals, they're existing in these pockets of extended space-time. So in the first orbital, you have one electron. And then because space-time is made out of light, right? Space-time is made out of light, volume by wavelength. Now, in the second orbital, then you can have 3, right, or 4 in the 2 squared. In the 3 squared, you can have 9 electrons, right? See what I'm saying? As the volume by wavelength increases, you get higher and higher amounts of electrons that you can have in each orbital. But when you add energy to the 1 squared, then that moves the electron up. So when you have a fire, then the heat rises in the same way. You have an expanding space of energy increasing the fire. And then that's the same way you get with the Hubble constant. So the fire goes to the sun, and the sun is also increasing that volume by wavelength as it's burning. So you get the Hubble constant, and the universe is expanding and stuff. And right, so the electrons move up, and then they move down. They emit a photon, right? Lastly, you get energy expanding states, right? Go from Bose-Einstein constant, solid, liquid, gas. That's from energy expanding space. And so we put the distance 4 pi r squared over volume by wavelength with, so it's E